Welcome everyone. I'm Ksenia Sternina, CBO at SODA and moderator of this webinar series. Today we continue our SDV Practical Series with the second episode, and our topic today is SODA.Validate product. In our first session, we introduced SODA.Validate, and now we dive deeper into its impact. I'm pleased to introduce Igor Zorin, product lead of SODA.Validate, who will guide us through how our AI-powered solution elevates automotive software validation. Let's get started.
Thank you, Ksenia. Hello, everyone. My name is Igor Zorin, and I'm the product lead of SODA.Validate. I'm delighted to welcome all of you to today's webinar. And yes, today we will focus on the core use case of test design, which touches on almost every aspect of our product. And in future episodes, we will dive deeper into details and showcase more complex scenarios. Okay. About our solution, SODA.Validate is a tool designed to ensure that solutions integrated at different levels comply with requirements, and it provides insights into the current system states and their readiness to vehicle certification. Simply put, we cover the key stage of the development process as presented on the right side of the module. This stage is particularly important as it is where developers and engineers verify whether the implemented functionalities aligns with original requirements. And with SODA.Validate, you can accelerate development and also reduce risks associated with identifying critical issues at later stages when fixing them becomes costly and time-consuming. What we will cover in this episode, today we will briefly go through vehicle topology creation, the definition of a fixed scope for release components, and take a detailed look at the process of creating test sets, cases, and as well as their implementation. In most cases, testers begin working with the system when they already have some set of requirements, whether they are high-level vehicle or functional or even system requirements, as well as architectural descriptions. So, yeah, this information forms the basis for the entire validation process. That is why our system provides convenient tools for working with these data sets in one place, along with automated solutions, including the AI assistant, which helps speed up validation and simplify the overall process. We'll demonstrate how to use this assistant to automatically analyze requirements, generate test cases, and optimize test scenarios. For those who watched the first episode, you may recall that Alexey Yakovlev showed the requirement definition process. And this stage corresponds to the left side of the V model. This process is managed using our SODA Create product. Initially, general requirements are defined, which are then refined and broken down into more specific functional requirements. And these are further decomposed into system-level requirements, specifying distinct functional blocks. Many of these blocks can be reused in other vehicle features, making the development process more flexible and modular. At the same time, the vehicle topology is established, defining the relationships between components and systems, which is crucial for their integration and subsequent validation. So at this stage, we already have enough information to create the sets, plans, and test cases, which include the description of necessary validations. However, the most exciting part begins when we integrate details about a specific vehicle and its architecture as a test environment for our ECU validation. With this information, our assistant can generate test code directly, let's briefly go through the core components on this test environment. The process starts with vehicle catalog, where we can find the existing one or create new one, just put their name and short description. After that, next, for each created vehicle, we need to define its hardware topology. This includes details about the communication networks. Let's go try to create a new one. On the right hand side, you will find the interface for adding network information, CAN, LIN, and actually in our roadmap plan, we have plans to support Automotive Ethernet. And on the left side, you can add details about ECUs and their network connections. Okay, let's try to do something. Okay, and now you can connect this ECU to this CAN network. Okay, let's go deeply to create one. Once the topology is defined, we can proceed with adding details about ECU firmware and connected simulation models and structured text files describing network messages and signals, which are DBC and LDF files. Briefly, what about simulation model configuration? This consists of a set of simulation models added as a separate step. These models are fine-tuned specifically for the current project and for release. And for example, let's take a brake pedal model. When the same model can be used across different projects, but with different calibration settings that adjust specifically for it. Or if you consider the smart device, it will most likely have its own configurable parameters, which can be adjusted based on the project requirements too. We can create it here. We can edit. 1 second. Here we can see the bundle of simulation models and their parameters, which are different from default one. And actually, we have a library of prepared simulation models. Let's try to add something else. Okay, briefly, deep dive to the simulation model creation and their tuning or calibration. We have plans to show it on the third series of our episodes. Okay. Next step is to fulfill the information about software versions. We plan to integrate an API for the OTA service, ensuring that ECUs would be flashed with specified version before testing begins. And additionally, we have plans to support virtual ECUs, which with selectable versions available directly within the interface. Okay. So now we have all necessary things like software requirements, architecture information, and we assume that this data is added once per project and only needs to be configured further as needed. Let's move on to test creation. Tests are located in the corresponding sections and can be created either manually or derived from any requirements. For manual creation, we need to define the test name, specify test steps. These are atomic actions that can be reused multiple times or shared across different tests, actually. We can create new one, or we can select from existing test steps. Oops. Okay, let's consider that it would be a test for braking pedal. Among the test steps, we also have initialization steps specific to our setup. For example, by default, our ECU modules are powered off, and we use relays to enable power supply. Similarly, we have finalization tests like power up ECU and power down. Okay. Oh. Title. Okay, let's have a look at existing one test. Something wrong with this name. So yeah, test steps can be created from scratch or selected from existing library. And now let's generate test step for our test. Let's add one for existing step. For instance, checking that there is no more voltage on the lamps pin. And let's try to do it automatically with our AI assistant. As you can see, interface highlights that at least one step is not implemented for current project, which is selected right here. And this step is here. And we have tip to add implementation. So we can write down some comments for our AI assistant to ask him to do something. Let's create a cycle with at least, I don't know, 1 second of waiting with interval of 50 milliseconds with a check for the absence of voltage. On that pins. Sorry. Yeah, after that, we should just click Control B or Command B for. Sorry, Control B. So now our AI assistant is working and taking into account the previous added information about the vehicle, about the models, about the CAN networks. And we actually using API from OpenAI language models. And actually we are working with Anthropic. And we have plans to implement our local language model to avoid security, some security problems. Okay, let's check what was proposed. There is a timeout for 1 second. Yeah, interval for 50 milliseconds. And the cycle, which ended within time. And yeah, our copilot proposed us to check the pins. And this voltage on the pins should be about 0. Let's try to check it right now. We have prepared a trick, and we can try would this solution or proposed step work or not. By the way, information about the test trick, that is, you can probably hear the click. Information about this rig and how to configure it would be on our next episode about Validate. So the click is supplying voltage for the ECUs. And right now we can check the report. And the report said that all validations were passed. And there are actually our new steps. So here you can check the report. It is standard robot framework report, and also CAN logs that you can download and check with your preferred software. So let's play a little bit more. Let's create tests from requirements. It can be done from every requirement. Would be a vehicle requirement like this. Yep. We can create requirements manually from each requirement, like in this case. It just creates a new test with link to this requirement. Or you can generate test with assistant from this section. Let's take, I don't know, the first one. Yep. Please generate us a test to verify these requirements. Because of this language model is not it's OpenAI, and there are some drawbacks of this. I mean, sometimes it takes 5 seconds, sometimes 55 seconds, and it couldn't be predicted. Oh, yeah, it's too fast. So the whole test design for the whole feature can be created in several minutes, but definitely it should be checked, verified, reviewed. But yep. Let's check what was proposed for this step, for these requirements. The requirement said that vehicle operator can manually activate the debit beam lights, and the test verifies that there is no voltage at the beginning of the test, and after that, manually activated and confirmed that debit beam lights are illuminated and there is a voltage. Let's fulfill this step with AI. Clicking by this icon, creating a generate the whole step suggestion, and you can review or you can change this code before the test just by adding some comments, and like in this example, and clicking Ctrl+B. The second attempt is obviously longer than the first one. It's not so talkative with us, but the step is said that confirms that debit beam are illuminated. And what Copilot is proposed to check CAN message that the message contains ones for these signals. But I would like to add some verifications for the pins. Oops, sorry. Okay, by the way, when we are waiting for the response, for next series, it would be an episode about rig and how to connect it, how to configure it, how to connect the ECUs and to the rig via harness. And third episode would be about simulation models, how to create them from Simulink, for instance, and how to implement them or import them to the studio, how to configure the whole bundle, Yeah, and if you have any ideas or questions about this process, I would like to discuss it. Okay, so our assistant proposed us to check that the pins of EOFR module, which is right model, contains at least 12 volts with precision 1% during the 3 seconds. We can actually define what time of checking should be there, and it is a method for taking precision. We have a library of our own robot framework keywords. Yeah, right there. And 1 second. This keyword. Message 1 second. No pins. Yeah, it shows the precision mode. You can change it to the absolute value precision or reliable value precision. For instance, it would be meaningful to add relative value precision for the values more than 0. It's nonsense to get percentage of 0. Okay, so in this case, I have shown you that how to generate test set or test design for the whole feature in a minute, but obviously it should be reviewed before the test execution. Probably that's all from my side. Ksenia, would you add something, or do we have questions?
We don't have any questions so far. So I think we'll wait just a couple of minutes if there are any. At the same time, if you can announce what's going to happen next in next series, a bit in more details, that would be wonderful, I guess.
Yeah, as I have mentioned, that second episode would be about the test rig, how to connect it, how to decide which models do you need for your ECU, because we actually have several models with different proposals, and how to create a harness between real ECUs. In future, we have plans to implement virtual ECUs to accelerate more your development process, and it's a teaser. Okay, and for the third episode, we are going to show and explain how to build simulation models from Simulink, and how to import them to the studio, and how to configure different, let's say, topologies or even vehicles with these models. We are going to do this with FMFMI models. So to expand the library, to share it between companies, we're really looking for this direction to create data model distribution between companies. So,
All
yeah,
right,
see,
and
yeah. The first question.
We have a question here. Yes. So, any opportunity to work remotely with Validate Rig?
Yes, definitely. We have, as you can see, there is my laptop and nothing more is connected with test rig, which means that you need only internet connection. There is actually another computer, a small computer like Nuke, and in future we will support Raspberry Pi as a server or executor for the code and for tasks for the rig. So you can have rig in one location and even several models in one location, other models in another location, and you can be in another country at all. And you can start the test. But it's a physical law to I mean, there would be some delays between communications, and if your project is not does not require fast interaction, it would be possible. And right now we are preparing the project, which is looks really like this example, where 2 or 3 companies would prepare their own parts of the whole vehicle. For instance, you can have a company that helps you validate or verify inverters in one country, like Spain, and BMS in France, and steering reels in Germany, and you can manage these tests from Australia.
That's beautiful.
Okay.
That's cool. And we have another question actually. Validate Copilot support OpenAI only or other LLMs?
Yes, as I mentioned it before, right now we are supporting API from OpenAI, but we're working on supporting Anthropic and our own local language models. So right now, yeah, we have only one solution, and as you can see, it depends on the time, on the day, on the workload of OpenAI services. And yeah, local language models will be propose your ability to not sharing data. And right now, it's this data is not sharing with the whole internet. But you can be sure that this information wouldn't be leaked.
And we have another one regarding the distribution of raspberries. Any suggestions for convincing the IT departments to get them integrated? Protocols, boards?
Okay, we're right now only thinking about this direction, and our solution has only a solution for nukes, on Linux-based nukes. But we are going to this direction to make our solution faster and lightweight to support Raspberry Pis due to their price and affordability. So yeah, definitely we'll create environment and probably rules, or we will create whole software pre-installed on the Raspberry Pis that would be secured from hackers. I don't know, and that would be connected only with SODA.Validate Studio to avoid any security risks.
Nice. And I would encourage everyone watching us to stay with us with the next episodes because we're going to update you on the new LLM models that we're going to integrate. And I guess in the next episode, we'll prepare some updates for you guys. For now, we don't have any other questions. So I would suggest that we close this session. Thank you so much, Igor. Yeah,
Thank you, Ksenia.
that was wonderful. Happy to see you all and see you next time.
See you.
Thank
Bye.
you.